in this video we will discuss about angle of friction, angle of repose, and the relation between angle of friction and angle of repose. So first of all, let us discuss what is angle of friction. So here you can see in the figure there is a rigid support, this one, a table you can say, and on that table an object is kept. Now a force is applied on the object in this direction, that is capital F. Apart from this force, one more force is acting on the object, that is the gravitational force, or we call it weight of the object, which is in vertically downward direction. W is equals to mg. M is the mass of the body, g is the acceleration due to gravity. Now since weight is acting in vertically downward direction and since the object is placed in a horizontal plane, the reaction force will act on the object in vertically upward direction, that is R, and the magnitude of reaction force, it becomes equal to mg only, that is weight. Okay. Now when this force is applied and suppose the object is not moving, then we will say that in between the object and the surface there is a frictional force, and we know that frictional force is in opposite direction to the applied force. So since the applied force is in this direction, frictional force will be in opposite direction, which is given by small f. Okay. Now angle of friction means this angle theta. Now how to define this angle? See, two forces we are considering here. One is the frictional force, one is the normal reaction. If you remember the concept of vector, the parallelogram law of vector addition, there you got that if two vectors like this one and this one forms two adjacent sides of a parallelogram, then their resultant is the diagonal of the parallelogram. So here this is the diagonal of the parallelogram, which is R dash. So here we can say that the resultant between frictional force, this frictional force, and normal reaction is this one, R dash. Okay. And theta is which angle? It is the angle formed by the reaction, angle formed by the reaction with the resultant vector. Okay, because this theta is angle between which two vector? The resultant vector and the normal reaction vector. So how we will define this angle of friction? I have written the definition here. It is the angle between the resultant of frictional force and normal reaction, which is R dash, with the normal reaction. Normal reaction is R. Okay. Now we will find a mathematical expression for this angle of friction. Suppose we know that some vectors are there which can be replaced, free vector, which can be replaced from this position to this position without changing their magnitude and direction. So here if I just shift this vector f to this position, then it forms a triangle, right? This forms a triangle. If I put this vector f here, then this forms a triangle, and if this is the triangle, then the base, if theta is this angle, then the base of the triangle is R, perpendicular of the triangle is which one? F, and hypotenuse of the triangle is R dash. So if I write tan theta for this triangle, tan means it is perpendicular by base. So tan theta perpendicular is which one? I have shifted this f vector here. So perpendicular is f vector, f by base is R, so f by R. Now again we have this formula, frictional force is equals to mu into R. You got this formula already. So from this equation we can say that mu will be equal to what? F by R. So now you just compare this equation 1 and equation 2. Right hand side is same, f by R, here also it is f by R. So that means left hand side should also be same. That means mu should be equal to tan theta. So mu is equal to tan theta from equation 1 and 2. So this equation says that mu means coefficient of friction is equal to tangent of the angle of friction. There may be question that show that tangent of angle of friction means tan theta is equal to is equal to coefficient of friction, that is mu. Okay, so in this way we can prove it. Then another angle is there, that is angle of repose, and this angle of repose is basically we observe it when an object is placed on a inclined plane, not on a horizontal plane. Here you can see that this was the horizontal plane, the object was kept on the horizontal plane, but in this case this is an inclined plane. See, like this is the horizontal plane. So this inclined plane is at how much angle? Is at angle theta dash with the horizontal, and the object is placed on the inclined plane. Now suppose initially this inclined plane was somewhere here like this, and the object was on this. So in that case the object will not slide down. But as you increase the angle of inclination, means theta. Initially, as I said, suppose the plane is here, then suppose the plane is here, and then suppose the plane is here. Okay, so that means gradually this angle is increasing, and for a particular value of angle, for a particular value of this angle, the object which is kept on the inclined plane will start sliding. Okay, suppose this is a horizontal plane, you kept the object here, certainly it will not slide. If you just change the inclination, means suppose this plane you are keeping the plane somewhere here. Now this is the horizontal one, the object is on this, suppose still the object is not sliding down, then you increase the angle horizontal. Now I have increased the angle again. Now the object is kept on this, and the object start to come down. So the angle, this angle at which the object kept on the inclined plane just starts moving or just starts sliding is called angle of repose. Just an example, suppose when the angle is 15 degree, the object is not sliding. When the angle is 18 degree, object is not sliding. When the angle is 20 degree, the object just starts to slide. So this 20 degree will be angle of repose. Okay, so I hope it is clear. So in this figure, which one is angle of repose? Theta dash is the angle of repose. Now certain we will resolve certain forces. Let us see how many forces are acting on the object. First one is gravitational force or weight of the object, which always acts in vertically downward direction. This is mg. Okay, this mg, it will have two component. If you remember, in resolution of vector we discussed about component of vector, sine component and cos component. So if this is a vector mg, we can resolve it into two parts. One is this one, which is mg cos theta dash. One is this one, which is mg sin theta dash. Okay, now this, if this angle is theta dash, then this angle is also theta dash. And why it is so? Because there was a theorem in geometry, if you remember, probably in class 10 only you got this one, this concept. See here, this one mg. Okay, this mg vector, this is perpendicular to this plane from the geometry, and this mg cos theta, this is perpendicular to this plane, perpendicular to this plane. Okay, now if the angle between this plane and this plane is theta dash, then the angle between their perpendicular is also theta dash. Now which are the two vectors which are perpendicular to this and this? mg, which is perpendicular to this, mg cos theta is perpendicular to this. So the angle between mg and mg cos theta dash, that will also be theta dash. I think it is clear. This is one vector, this is one line, this is another line. Okay, how much angle they are making? Theta dash. Now where are the perpendicular of this line and this line? The perpendiculars are, one is mg, the other one is mg cos theta. So angle between them will also be theta dash. Okay, so if it is so, if this angle is theta dash, certainly this component will be cos theta. Okay, for better understanding you can just go there in vector chapter, you can see that part, resolution of vector, and there you will understand that one component, this component will be cos theta component, and this component will be sin theta. Now due to this component mg sin theta dash, which is this side, the object starts sliding. Okay, but at the point where the object just starts to move, we can say that some frictional force is also acting on the object. Since the direction of the object is direction of motion of the object is this side, frictional force will be in backward direction, which is F, and this force and this frictional force will balance each other. Okay, but as the object starts moving, that is the limiting case. We know this one, that limiting friction, and limiting friction is the maximum value of what? Static friction. So in limiting case, this and this will be same, but once the object starts moving, okay, then what will happen? Then this will be more than this. But at the limiting case, when it just starts to move, in that case we can say that this thing is equal to this, and the reaction is equal to mg cos theta, because you see this one, reaction is in upward direction, mg cos theta dash is in downward direction, both are on the same line. So that means what? They are opposite and equal. Okay, so here two equation we will make. One is r is equal to mg cos theta dash, another one is f is equal to mg sin theta dash. Okay, so for that, here I have written this two equation, this one and this one. Then 1 by 2, if you divide f by r, this side mg will get cancelled, sin theta dash by cos theta dash, it gives us tan theta dash, and again from this equation f equals to mu r, we can say that f by r is equal to what? Mu. So we got same kind of equation. See here, mu equals to tan theta dash, here we got mu equals to tan theta. So can we say theta and theta dash are same? Yes, numerically they are same. So theta dash are same. So that means angle of friction is equal to angle of repose. There may be proof that show that angle of friction is equal to angle of repose. In that case, you have to start from here. First you have to find the expression for angle of friction, then you will find it out for angle of repose, and then you will conclude that angle of friction and angle of repose both are equal. Thank you.